Hi everyone, it's Christina, and in this video, we're continuing our Edexcel 2018 A-Level Mathematics Paper 1. We're now looking at question 5. So let's have a look here. We're given an expression for y. So we have our trig functions here. We have y equals 3 sine theta over 2 sine theta plus 2 cos theta. And we're given a range of values for theta as well. We want to show that, so we have a slight typo. So this should be dy over d theta equals a constant a over 1 plus sine 2 theta. So that should be theta there. Okay, so now that makes a bit more sense. So really, we just want to find a way to differentiate this expression for y. So the best way to differentiate this thing here is with the quotient rule. So it's a quotient rule for differentiation. Okay, so let's try and recall what that is. So if you have a function y and you can split it into two functions u and v, which are in fraction form, so that's the quotient part, we have u over v, then to differentiate that, typically we'd have it as differentiating y with respect to x. I'll just write it like that for now, and then we'll change it to y and theta. So dy over dx would be v times du over dx minus u times dv over dx all over v squared. So that's a bit like an r, so let me write that as v squared. Maybe I'll rub it out. There. Okay, so now let's assign our expressions for u and v in this question. So u is probably going to be our 3 sine theta. So this is our u. And then our v is going to be what we have in the denominator. So that's going to be 2 sine theta plus 2 cos theta. So that's v. Okay, and we'll write it down here as well to make it super clear. U is 3 sine theta, and v is 2 sine theta plus 2 cos theta. And I'll also label this here. This is our quotient rule. Okay, so now what we also need is we need u and v differentiated, but of course, in our case, we're differentiating with respect to theta instead of x. So let's do that. Du over d theta, so we'll do that first. So if we try to differentiate 3 sine theta with respect to theta, we're going to get 3, that stays the same, that's just a constant. And then sine theta differentiates to become cos theta. So du over d theta is actually 3 cos theta. And then if we do the same thing for dv, so we're finding dv over d theta. So what we need to do is we differentiate each term separately. So 2 sine theta, when we differentiate that, we get 2 cos theta. And then we want to differentiate 2 cos theta. That's actually going to give us 2, so plus 2 times cos theta differentiates to give minus sine theta. So I'll rewrite that down here. So in fact, that becomes minus 2 sine theta. Okay, so now that we have all that, we just need to substitute everything in. Now, this might seem like the easy part, but you can make mistakes here because we have quite long expressions that we're having to multiply by. So let's see what happens here. So we get dy over dx equals v. So v is 2 sine theta plus 2 cos theta. And then we have du over dx. Well, that's our du over d theta. So that's 3 cos theta. And in fact, I've written dy over dx. I should have written dy over d theta. There we go. Minus u, which is 3 sine theta, times dv over dx. In our case, dv over d theta. So that's this here. So that's 3 sine theta times 2 cos theta minus 2 sine theta. So you can see here that it's starting to look a little bit more complicated. So we just have to be very careful with our multiplication. All over v squared. So that's, we're doing 2 sine theta plus 2 cos theta all squared. Okay, so now let's multiply everything out and see if we're able to simplify anything. So when we multiply things out, let's take the first term and then multiply it by our 3 cos theta. And then we're going to take the second term and multiply it by 3 cos theta. So the same rules for when you're multiplying through by a term outside of the brackets. But just be careful because, of course, the trig functions can be very confusing. So 2 sine theta times 3 cos theta, that's 6 sine theta cos theta. And then we have plus 2 cos theta times 3 cos theta. Well, that's plus 6 cos squared theta. And then minus this entire expression here. So sometimes it's easier to deal with the signs if we kind of draw square brackets around this, because it might be very easy to miss this negative sign. You might do minus 3 sine theta times 2 cos theta, and then forget that this minus needs to also be multiplied by this minus. So instead you get minus this and then minus 2 sine theta, 3 sine theta. That's not going to give you the right answer. So we need to be very careful when multiplying out not only of the functions themselves and the expressions that we get, but also the signs in front of them. So be very careful of that. So here we have minus 6, so 3 sine theta times 2 cos theta, that's 6 sine theta cos theta. And then we have 3 sine theta minus 2 sine theta, that's minus 6 sine squared theta, like that. And so now you can see this term will have a negative sign in front of it, but this term actually becomes positive because we're doing a negative of a negative term there. Okay, and then the denominator, it might be easier to write this as a double bracket. So 2 sine theta, 2 sine theta plus 2 cos theta times 2 sine theta plus 2 cos theta, and then multiply it out from there. So on the next line, what I'll do now is I'll just simplify the numerator first, and then I'll also write out the terms that we get from multiplying out these brackets. So at the top here, I'm going to get 6 sine theta cos theta, but here I'm going to get minus 6 sine theta cos theta. So in fact, these two terms end up cancelling, which is quite lucky. So we get 6 cos squared theta. And then the next term I get from this is minus 6 sine squared theta. So minus of a minus, that's positive. So I get positive 6 sine squared theta. And even before I start to work out the denominator here, you might recognize that, I'll write it like this, cos squared theta plus sine squared theta equals 1. okay? And in fact, this expression here, we just have a 6 in front of our cos squared theta and our sine squared theta. So imagine then we just multiply the left by 6. So 6 cos squared theta plus 6 sine squared theta. That just gives us 6 because we have to multiply everything on the left. Or everything, we have to multiply everything that we multiplied on the left by the same thing that we multiply on the right with. So that means that 6 cos squared theta plus 6 sine squared theta is going to give us 6. So this entire expression here just simplifies to give us 6. And that comes from our expression that we learnt. One of the first things you learn, your trig identity. Okay, so I'll just keep that there for a second and then I'll rewrite it because I want to show you what you get when you multiply out these two brackets. So in multiplying out our brackets, we're going to do 2 sine theta times 2 sine theta first. That just gives us 4 sine squared theta. And then we're going to, still with the first term of our first bracket, then multiply out the second term of our second bracket. So we're multiplying 2 sine theta by 2 cos theta. That's plus 4 sine theta cos theta. Then we want to look at the second term of the first bracket. Okay, so our FOIL method applies here as usual. So 2 cos theta times 2 sine theta. That gives us plus 4 cos theta sine theta. And then the second term of the first bracket, we are finally going to multiply it by the second term of our second bracket. So 2 cos theta times 2 cos theta, that's just plus 4 cos squared theta. Okay, so now I'm going to rewrite the top. So we established that the top just gives us 6, so that's our numerator. And then we're doing all over. Let's simplify this a little bit. We have 4 sine squared theta plus 4 cos squared theta. Okay, well, by the same logic that we used before, that's just going to be 4 because sine squared theta plus cos squared theta is 1. And if that's confusing to you, then you can have a look at one of my earlier videos on trig, A-level trig functions and identities. So you might find that useful just to revise before you attempt this question. So 4 sine squared theta plus 4 cos squared theta just gives us 4. And then what do we have remaining? We just have 4 sine theta cos theta plus 4 cos theta sine theta. These two are exactly the same. The terms are just swapped around, but because it's multiplication, we can do that. So we just write 4 plus 8 cos theta sine theta like that. Okay, so from here, we just need to double check what we actually want. Okay, so it's actually dy over d theta equals a over 1 plus sine 2 theta. So we want to show that we get a constant over 1 plus sine 2 theta. So this thing here, can we rewrite this? If we recall our double angle formula, so our trig double angle formula. I'll write formulae because obviously there are multiple, but this one here specifically, we have sine 2 theta is equal to 2 cos theta sine theta. We have cos 2 theta. So I'm just going to write a few of them down, and this is how I would suggest you do it if you do get stuck. But if you just write down the trig double angle formulae that you have, try and recognize the form of what you're being given. If you're not able to recall it immediately, which is perfectly fine. So sine 2 theta, cos 2 theta is 2 cos squared theta minus 1. Remember, this can also be written as minus 1 minus 2 sine squared theta. I'm just going to stop there. Obviously, there are a few more we could write, but let's just stop there for now because we actually have it here. So 8 cos theta sine theta. What does that look like? Well, it's this one here. So it's a sine 2 theta. And you may have recognized that immediately, but just in case, if you do get stuck, just write them out and then compare it to what you're given. So we have 6 over 4 plus. So we have 8 in front of our trig expression here. And for sine 2 theta, it's a 2. So 8 cos theta sine theta is equivalent to writing 4 lots of 2 cos theta sine theta, right? 4 times 2 is 8. And so if I just, I'll go down here actually. So 6 over 4 plus 4 lots of 2 cos theta sine theta. Well, that's sine 2 theta. Like that. Okay. And so, oh, if I just go back up here, we have a over 1 plus sine 2 theta. So we want it as 1 plus. So because we have a 4 there instead of a 1, we actually want to divide everything by 4. So if I scroll down. So here we want, the form that we want is I'll write it in red so we know that that's our goal. dy over d theta equals a over 1 plus sine 2 theta. So what we want to do is if we divide everything by 4, so each term by 4, then we'll get the denominator in this form, and then we can read off our value for a. So let's do that. So we have 6 over 4 all over 1 plus sine 2 theta. And so our 6 over 4 is actually our a. So here we can just write our value of a equals 6 over 4. And therefore, I'll write the whole thing here. Our dy over d theta is actually 3 over 2. Now, because we're going to write it in this fractional form, I'll just write it as 1.5 over 1 plus sine 2 theta. Okay, so that's how you tackle question 5. And initially, you might think the differentiation itself is the most difficult part. But in fact, I think the most difficult part really was multiplying everything out and making sure that we weren't making a mistake. Okay, so in the next video, I'll be going through question 6.